We've been solving systems of equations where we come up with an answer. So we're going to solve some special ones today. First thing we're going to do is we're going to talk about classifying these different systems. There's basically two big classifications. There is what we call consistent, which means that there is a solution, and then inconsistent, which means there is not a solution. Now, in the consistent camp, there are two different types of solutions. There's what we call an independent one, where they have absolutely one solution, which would be that point right there, that point of intersection. And then we have dependent, which means there's an infinite number of solutions. What that is that's two lines that lay right on top of each other. Okay? That means every point on one line works in the other line, so they have an infinite number of solutions. Inconsistent would be the parallel lines, and we're going to see how we can find those out. So we're going to go ahead and solve this using any method that you want. I'm going to look at this one, and I think that the method I would choose for this one would be substitution, because the fact that this is already isolated. So I'm going to take the x minus 4, and I am going to substitute it into the second equation in place of a y. So the x minus 4 goes here, and that equals 3. And then I'm going to combine like terms. Well, a negative x and a positive x gives me no x's, so I end up with negative 4 is equal to 3. Well, that's weird that the variables disappeared. Well, what that means is it means that it is a special system. In this case, the equation that we have left is false, and that's like it's telling us that this is never going to happen. There will never be a solution to this system because this is false. No solution. Now, let's see what this looks like if we were to graph it. I would first want both of these to be in slope-intercept form, so I'm going to add x to both sides here, and I'm going to get y is equal to x plus 3. So for the first equation, I'm going to start at negative 4. I'm going to have a slope of 1, up 1, right 1, up 1, right 1. Draw my line. Okay? The second one's going to start at positive 3, a slope of 1, up 1, right 1, up 1, right 1. And you should see that you have parallel lines. Those lines look horrible, but those are parallel lines. All right, what do you notice about parallel lines? They have the same slope. All right, let's try this one. Again, solve using any method that you want to. I think maybe this time I will use elimination. I will set them up by adding y to both sides. So that's going to give me y is equal to 3x plus 2 on the bottom, and y is equal to 3x plus 2 on the top. Now, I'm thinking that you're looking at those thinking, okay, those are the exact same thing. Let's go ahead and multiply the bottom one by negative 1, which will change the signs, and add them together, and that's going to give me 0 is equal to, that's a 0 is equal to 0. In this case, what we end up with is a true equation, which means regardless of what you put in here, you are going to get an answer for this. So that means there is an infinite number of solutions. And let's see what that looks like graphing. Now, both of these are already in slope-intercept form. So this one starts at 2, has a slope of 3, up 3, right 1, up 3, right 1. So I have a line that goes right along here. And when I go to graph the second one, I'm going to start at 2 again. I'm going to go up 3, right 1, up 3, right 1, and you will notice that this second line is right on top of the first one. Okay? Now, both of these this one is an inconsistent system because it has no solution. This is a consistent solution, but it is dependent because the two lines are right on top of each other. So there's our classification. Okay, you notice in the last one I came up with 0 equals 0. That's a true statement. It does not mean that it has no solutions or that the answer is 0. It simply means that it's a true equation, and so that means that they are the same line. Okay, so now let's kind of summarize this. This would be a great thing to write down somewhere. These are our three classifications: consistent, independent, consistent, dependent, and inconsistent. All right, If it's consistent and independent, you're going to end up with one solution, and you will actually end up with x is equal to a value, y is equal to a value, and you write your answer as an ordered pair with your x and y's. If it is consistent and dependent, you're going to end up with an infinite number of solutions. And what's going to happen is your variable is going to disappear. Variable gone. And you end up with a true equation. If it's inconsistent, that means that you have no answer, no solution. Again, when you're solving it, the variable is gone, but you end up with a false equation. Now, just looking at equations, how can you tell? If it's consistent and independent, they will have different slopes. Okay? That's it, in a nutshell. If they've got different slopes, they're going to cross somewhere. If they are consistent and dependent, they will have the same slope. So they're going to have the same slope and the same y-intercept. If they're inconsistent, they will have the same slope but different y-intercepts, and that's what makes them parallel. If you look at the graph, it's very easy to see. If you're graphing them, they're going to have one solution right there, same line, infinite number of solutions, parallel lines, different solutions. Okay? Let's try a couple. Go ahead and solve it using any method that you want, and then let's check our answer. I'm going to multiply this bottom equation by 3 to get rid of the variable, and that's going to make that a negative x plus 3y is equal to 3. On the top one, I'm going to subtract x from both sides to line these up. That's going to give me negative x plus 3y is equal to 3. Now, I can go ahead and continue to solve this using elimination. I can multiply one of these by negative 1, but I also can see right now simply by setting them up, they are the exact same thing. I'm going to end up with 0 is equal to 0, which means this is a true statement, which means they do have solutions. In fact, they have an infinite number of solutions. Let's try the next one. Again, decide what method you want to use to solve it. I think maybe I would like to use, let's use substitution. Let's multiply everything down here by negative 1. That's going to give me a negative 4 plus negative y is equal to x. I'm going to take this, substitute in for x, so that's going to give me negative 4 minus y plus y equals 5, which is going to give me negative 4 is equal to 5, which is a false equation, which means no solution. That means they are inconsistent. Okay, these almost get easy. All right, this one I'm probably going to use substitution because this is already isolated, so I'm going to take this and substitute in for y. So that's going to give me 4x plus 1 minus 3 equals x. That's going to give me a 4x plus 4 minus 3 equals x. That is going to give me a 4x plus 1 is equal to x. Subtract 4x from both sides. 1 is equal to negative 3x. Divide both sides by negative 3. X is equal to negative 1/3. Now, I know for a fact that this is a consistent, independent situation because I am getting an answer. Okay? Since I use substitution, I'm going to substitute back here into the original equation, and that's going to give me 4 times negative 1/3 plus 1, which is 4 times 2/3, which is 8/3, and there is the second part of my answer. Okay, we're going to go ahead and apply this to a word problem. Jared and David both started a savings account in January. If the pattern of savings in the table continues, when will the amount in Jared's account equal the amount in David's account? So the first thing we need to do is write an equation. We need two things. We need the y-intercept, our beginning value, and we need the slope or the rate of change. Here, so for Jared, the beginning value is 25, and he goes up how much each month? $5. All right, for David, the beginning value is 40, and he goes how much each month? $5. So let's write equations for both of these guys. All right, so y is equal to 5x plus 25. And for David, y is equal to 5x plus 40. Now I'm going to solve this. I would probably use substitution for this. Take this, put it in for y. 5x plus 25 is equal to 5x plus 40. Some of you may be questioning this already. Let's go ahead and get all the variables on one side. Subtract 5x from both sides. Okay, what happened then? Gone, gone. 25 is equal to 40, which means Jared will never save as much money as David. And many of you are thinking, well, that can't happen anyway if they're saving the same amount every month. So, and that's how we use it. And that's it.